A very good evening, students. So today we are going to do another type of assignment problem, which is known as restricted or prohibited assignment problem. And here the question number 75 is an example of that question or that type of question. So you can see here there is a statement, and thereafter we have a matrix, and you can see there is hyphen, or we also call it as a dashes. What it means that M2 cannot be assigned to C. Here is the dash. It means that M3 cannot be assigned to A. Usually restricted assignment problem deals with where resources have some restrictions in relation to some activities. Let's get it clear with a real life example. We have a 4 persons, A, B, C, D, E, and we have a 5 activities. So you guys also know that it's not possible that each and every person will be good in each and every activity. Usually what assignment takes, that each and everyone is able to do each and every activity. Yeah, it is different, their efficiency or their productivity can be different, but each and every can do each and every activity. Each and every resource has a capability to perform each and every activity. Okay, but in real life what happens, it may be possible that you are good at accounts but you are not good at taxes. You are good at account management, HRM, but you are not good at taxes, so you should not be assigned the tax department. In that way, that is a restriction which has been imposed on you, that you should not be assigned the tax department. In the same way, some other person may be not good at accounts, or he is not able to, or he is not comfortable with accounts. He don't have any you can say a little bit knowledge of accounts, how to deal with it. In that case, that particular department or subject will not be assigned to that particular person. So that is a kind of restriction problem. So in this case, what we have, I'm going to read the statement. In a modification of plant layout of a factory, 4 new machines M1, M2, M3, M4 are to be installed in a machine shop. So we have a machine shop and we are going to install 4 machineries, machinery 1, 2, 3, 4 in that machine shop. There are 5 vacant classes. We have a 5 vacant classes, A, B, C, D, E. Okay, or you can say the rooms. Because of the limited space, we have these are the rooms A, B, C, D, E. So these 4 can be assigned to these 5 rooms. Okay, so machine 2 cannot be placed at C. What they are saying, machine 2 cannot be placed in room C, and machine 3 cannot be placed in room A. It may be due to the reason of their size. It may be due to the reason of their size, because sometimes the machineries are getting heavy, or their requirements are different, and those requirements cannot be fulfilled in these rooms. So there has been a restriction imposed on machine 2 that it cannot be installed on C, and machine 3 that it cannot be installed in A. So that is a kind of restricted assignment problem. And how to solve them? There is no specific, or you can say unique method, or nothing else we have to do. As earlier we were using our balanced matrix problems. In that way we guys are going to solve it, or we are going to take it as a minimization, because what we have to do, we have to assign, and that is a cost of assignment. That is here the cost in rupee in shown below. So that is a cost of assignment, so we want to minimize the cost, so that will be our minimization problem. That is, the assignment problem is of a minimization. If there was a productivity, so it will be a maximization, but here it is cost in rupees, so that's why it is a problem of minimization. Further, you can see that we have 4 machines and 5 rooms, so it means that 1 room is going to be vacant. It means that is a problem of unbalanced matrix. So what we have to do, we have to make it balanced, and we are going to introduce machinery 4, which will be the dummy machinery. Okay, now let's do it on our notebook. For the convenience of you guys, I already have copied that material on this page, that matrix, and it was a cost matrix along with an unbalanced problem. So what to do in unbalanced problem? We have a number of columns are 5, number of rows are 4. So what we are shorting off? We are falling short of a row. So what we are going to introduce? We are going to introduce a dummy row. I am giving it a name of M5, and further you can write somewhere that M5 is a dummy row, and the values will be in that row will be 0 0 0 0 0. Okay, now what to do next? We are going to do row reduction, as simple as we were doing earlier. Problem is of minimization, so it will be start from row matrix. If the problem was of a maximization, first of all we were going to convert it into the loss matrix, and thereafter row reduction, column reduction, making assignment improvement, until we are not reaching our solution. Okay, so let's do it. Row reduction. So here is row reduction: A, B, C, D, E, M1, M2, M3, M4, M5. Okay, so what is the smallest element in that row? 9. So 0, 2, 6, 1, 2. What is the smallest element in this? 9. So 3, 0. And here is the restriction, so we cannot make an assignment to this. As we have done in a traveling salesman problem, there were restrictions that we cannot move from the same city to same city. Okay, so 10 minus 9 1, 9 minus 9 0, again dash, and here smallest element is 7, so 11 minus 7 4, 14 minus 7 7, 11 minus 7 4, 7 minus 7 0. Again the smallest element is 7, so 7, 14 minus 7 7, 8 minus 7 1, 12 minus 7 5, 7 minus 7 0, 8 minus 7 1. Okay, and in the last row will be the same. Now we are not in need to do column reduction. Reason being, we have at least a single 0 in each and every column, so directly we will move towards making assignment. So we are going to make assignment in this table. Okay, so in starting, what we are going to do, assign single 0 in row or column wherever we are going to find out. And how to find out? First row, is there any single 0? First column, is there a single 0? In that way. Okay, thereafter again we are going to look at the second row, and thereafter into the second column, thereafter in third row, third column, fourth row. Okay, so let's have a look in first row. Is there any single 0? Yes, we are going to make an assignment, and we will cross every single 0 present corresponding to it. Now first column, no, we cannot make an assignment because it already has been done. Second row, is there any single 0? No. Second row, is there any single 0? No. Third row, yes. So the assignment is row wise, so we are going to cross every single 0 present in the column. Done. Third row has been done. Now third column, is there any single 0? Yes, so we are going to make an assignment here, and we will cross every single 0 present there. Done. Third column. Fourth row, is there any single 0? Yes, so we are going to make an assignment here. And we will cross every single 0 present in corresponding, no zeros are present. Thereafter fifth row, fifth column, once we have completed. Now what to do? Again same procedure. First row, first column, second row, is there any single 0? Yes, so we are going to make an assignment of this. Okay, now look at the requirement of our solution. Number of assignments should be equal to number of rows or column. So these are 5 and 5. Done. So we are at our solution. Okay, now next, how to write a solution I already have explained the things that how to write the solution, but again I have to write the solution. M1 has been assigned to A. Machine 1 has been assigned to room A. Machine 2 has been assigned to room B. Machine 3 has been assigned to room E. Machine 4 has been assigned to room D. Machine 5 has been assigned to the C. Okay, done. And how to write the values? What are the values? Means the cost that we are going to face. M1 is to A1 9, M2 to B, that is again 9, M3 to E, that is 7, M4 to D 7, M5, the values for M5 will always 0. So the total value is 9, 9, 18, 18, 7, 25, 27 and 7, 34. Okay, 34 or 9, 9, 18, 25 plus 7, 32. So our minimum cost will be 32. Okay, that's our solution. Is it okay? There is nothing different from any other problem of minimization or maximization. Restricted assignment, whenever we are going to have a restricted assignment problem, you shouldn't get worried. That is as simple as the balanced problem. Okay, and for the time being we hadn't done any improvement here, because our number of matrix was equal to number of, you can say, number of assignments were equal to number of rows or columns, so we have arrived at our solution. Okay, so that is our restricted assignment problem. Okay, have a good day.